Okay, so today we are talking about linear functions. The first thing we're going to talk about is function notation. So this is a method for writing variables as a function of other variables. So in function notation, the variable x becomes a function of y. So our notation is going to be f of x. So like think about it how like all of you guys have names and I don't just call you people. This is what I'm doing here with function notation. I'm giving it a special name. So this function's name is f. So it's going to let the variable x be used to find the value of y. We've done this before. It's just replacing y with f of x. So we're giving it a name. So if I think about my equation, y equals f of x, nope, what am I reading? Y equals 5x plus 1. We want to write this in function notation. So we have our inputs, which are domain or range. And then it's going to come out with our outputs. And these are our range. So the way I write this with function notation is literally the y gets replaced with f of x, and then I just write the rest of the function the same. So 5x plus 1. So this wants me to find the value of g of x equaling 5x plus 1 when x equals 3. So what I'm going to do is I'm going to plug in 3 for x. So I'm going to do 5 times 3 plus 1. What is 5 times 3? Yeah, so I get 16 out. So I'm going to write my answer as g of 3 equals 16. This means that when I plugged in 3, I got out 16. So the next part wants me to evaluate the functions when x equals 5. So this first one, I'm going to plug in 5. So everywhere it says x, I'm going to replace with the number 5. So the left side is just going to stay h of 5. This is just telling me I've plugged in 5 into this function. And then 7 times 5 is? 35. And 35 minus 1 is? 34. Okay, so same idea for b. I'm still plugging in 5 for x. What is negative 2 times 5? And then negative 10 plus 1? Oops. Negative 9. Okay, so on the next slide, we have this graph. It wants us to answer the following questions. So, when it says f of 3, this means find the y value at 3. If I go and look at my x value of 3, what is my y value right there? Negative 2. Okay. So same thing for the next problem. I want to find my y value at x equals 5. What did you say it was? Negative 4. Okay, so this next part says, using what you know about function notation, given f of x equals 2x plus 3, consider the following. A is f of x equals 15. So this is the same thing as saying y equals 15. I'm going to set the equation equal to 15. Okay, so what do I want to do here to solve? This is just like what we did first semester. Yeah, subtract 3 on both sides. So 15 minus 3 is... And how do I get x all along? Divide by 2, because currently it's being multiplied, so I want to do the opposite of multiplication. So 12 divided by 2 is... So, just to recap, the output was given. That means we want to take our function and set it equal to 15 and solve for x. Okay. So for b, what do I want to do to solve this? So I'm going to have 31 equals the 2x plus 3. And then what do I want to do? Yeah, I want to subtract 3. So 31 minus 3 is 28. And then I want to... Bless you. So my answer here is 14. Okay, so last thing we want to do is we want to use a graph with the notation written like this. So this is saying f of x equals negative 5. What is x? So what is x when y is negative 5? Okay, so what is my x value there? No, that's the y value. Yeah, 6. So same thing for the second one. It's what is x when y is -1? So this one's crossing it twice, so what's the x value at both those points? Okay, so our final thing is, what's the difference between f of x equals 5 and f of 5? So f of x, oh, I didn't unfreeze. Well, but what is the meaning? What's the difference in the meaning? So what about the one that equals 5? Is it giving me the output or the input? The problem's giving me the input? It's giving the output, and I want to find the input. And then f of 5 gives the input. Find the output.